Several years ago, I went to a conference in London, and I got to meet Sir Tony Hoare, who was the creator of the Algol language, among other things. If you're interested in the history of programming languages, he's a name that pops up. He was an early innovator in the 60s of many different programming technologies, including, like I said, Algol. Sir Tony was responsible for many things, but one thing that he very much regrets and calls his billion-dollar mistake was inventing the null pointer. It seemed so easy at the time and so harmless, and he didn't quite realize what a disaster it would be. But the concept of a null pointer is simple. When you expect to get back a value from some function, and suddenly you get back lack of a value. So for example, you might call a function get user from database. You're going to get the a user record from the database. And you just call it. Now, under normal circumstances, that would give you a user record. But of course, it could also give you no user record, because what if the user doesn't exist, or something like that? So think of it as like going into a room and say, I'm looking for Dave. Well, people might say, yeah, that's Dave over there, or they might say, there's no Dave here. So you have both of those options. The problem is you then have a value that could be a value or could be not a value that could happen anywhere. In JavaScript, this shows up with the error message frequently. Undefined is not a function, where a value that should exist doesn't. In typed languages, you get similar things, and they're called things like null pointer exceptions or something like that. But the idea is the same, where you expected a value to happen, and it didn't. Think of this as you're trying to have a conversation with Dave, but there is no Dave. You look pretty silly. This has been responsible for, as Sir Tony said, billions of dollars of errors in real-world software, including in JavaScript. In Elm, it's rather nice because we use the maybe type to solve this problem, so that we differentiate, on one hand, between a value and a possible value. So get user from database will either return just user, or it will return nothing. And you have to differentiate between those two cases, or the system will fail at compile time. So there's no chance that when you're expecting a user record, you'll get nothing. So this prevents a whole range of errors from happening in the way that you expect that, okay, we know that this value, which should be there, will be there, and we can prove that mathematically, or that we can say we know that this value may or may not be there, and then we will, in our code, take steps to deal with either case. Maybe we'll say, okay, if the value exists, display it. If it doesn't, display no such user. That is a valid possibility. But it's a possibility we must account for in our code, or the compiler and the type checker will simply fail to allow us to do it. Whereas in JavaScript, you see undefined is not a function, or worse, the word undefined, your last command was undefined. That's not the situation you want. So in Elm, we take this class of bugs that could happen at runtime in JavaScript, or even in Java, and via the type system, we make it go away completely. So there is no undefined is not a function in Elm. In fact, there is no undefined. And that we know that all paths through a program lead to valid values. And that takes a whole class of bugs that you could have in a language like JavaScript, or even a typed language like Java or C++ or C, and just makes them go away. They cannot happen. And that's great, because a bug that cannot happen, and you've proved that it cannot happen through formal methods, which is what the type checker is one you have to worry about. It's not going to be something your boss calls you yelling at you about at 2 in the morning when a big customer demo halfway around the world suddenly went wrong. And that is a level of confidence I like in my code.